Good afternoon, students. Welcome back to the open elective course Fundamentals of Database Management System. In our last class, we completed the discussion on data independence. We have seen that data independence can be of two types. First, what exactly is data independence? We had a detailed discussion on different kind of schemas, like external schema was there, conceptual schema is there, internal schema is there. External schema was mostly used for the users, any user who uses the database, particularly the end users, we can say. The end users who uses the database, they are mostly looking at the external view or external schema. Then after conceptual schema is there. Conceptual schema is mostly meant for the database designers or the database administrator, those who handle how the database will look like, kind of how it is structured, all those things. The last schema was internal schema. That internal schema is mostly handling about the physical storage of data. Like in conceptual schema, we say how the data will be stored and how exactly it is stored in the database. That is something handled by the internal schema. Based on these three things, we have seen there are two kinds of data independence. One is the logical data independence, another is the physical data independence. So the data independence, basically it means that when we are trying to change one particular schema, then if we are changing a lower level schema, we should not making any change to the external level schema. So what we are trying to say here, making any change to the lower level schema without making any change to the external level schema, that is something called data independence. Now data independence is of two types. One is logical independence, another one is physical independence. In logical independence, we have seen that we want to make any change to the conceptual schema. So we should only change the conceptual schema things. There should not be any effect on the external schema. Similarly, the same thing we can apply to the physical data independence. In physical independence, we are trying to change only the internal schema. There should not be any change on the conceptual as well as the external schema. So up to this we discussed in our last class. In today's session, we are here to discuss on the database DBMS type, then what are the different languages, what are the interfaces, and what are the tools available in the DBMS. Okay, so let me minimize this screen so that you can see this slide. This is our presentation, DBMS types, languages, interfaces, and tools. We are in session 5, and as I usually do, the PPT is already uploaded on your CO1 course content folder. Once I complete this recording, I'll upload the video also on the course web page, so you can refer the LMS and you can get the things. Okay, so moving towards the topic, as we say, we are going to discuss DBMS type, languages, interfaces, and tools. Now this particular part we have already discussed in our last discussion when we were discussing about different kind of schema or database. We have seen that there is something centralized and distributed kind of database. So centralized database, had we know, all the data is located at a single site, means one point of location all the data will be stored. What facility it gives? It allows you a greater control over accessing and updating data. Now that is something a natural thing. If you are putting everything at one particular location, then it will be easy to access and update. But it has a disadvantage also. What is the disadvantage? It is vulnerable to failure as they depend on the availability of resources at the central site. Now when we are making the things at one location, the advantage part is we can access and we can update the data very conveniently, very efficiently. But the disadvantage of this part is, the disadvantage lies since everything is stored at one particular location. If our central site suffers some kind of damage, then the entire database will come to the halt. Means we cannot continue with the database because our central site is damaged. Okay, so you can see one example here given. Distributed database is something. Here the data is divided into different locations. In centralized database, the data was combined together at one particular site. In distributed, it is scattered at different locations. You can see the database is stored on several computers, from personal computers up to the mainframe systems. So there are different locations where the data is stored. The smallest, if the data is not so important or not so sensitive data, then we are storing in personal computers also. If there is sensitive data which will be handled by different users for different purpose, sensitive purpose, say those kind of data are stored in the mainframe systems. Now computers in a distributed system communicate with one another through various communication media. Now since we are storing data at different computers at different places, we need a communication medium so that the data can be communicated from one side to another side. We can achieve this by using high-speed networks or telephone lines. Now distributed databases are geographically separated and managed. As we say, the data we are storing at different locations, so obviously they are geographically separated. Once the things are geographically separated, we need to manage the data properly. Okay, they are separately administered, and it usually suffers through a disadvantage called slower interconnection. Now since the data is present at different locations, so it will take some time for the data to travel from one location to another location. Okay, that is the same thing you can see with the help of a diagram. This is the example of a centralized database. You can see that everything is centralized here. From this database server, different ATMs are getting the data. Now the same thing we are doing here, distributed database. Here one database server is here, another database server is here, another database server is here, and all the servers are connected through some internet link, or we can say telephone lines kind of. So this is the example of centralized database. This is the example of distributed database. Here also you can see this is our entire data is stored at one single site. So if this site suffers any problem, then entire database will come to a halt. Here if one server is down also, then also we can work with the rest two servers. Obviously the efficiency will be slightly decreased, but our network will be there, database will be existing. Okay, so moving further, languages, interfaces and tools in database management system. Now first of all we will go for the languages. The most widely used language in DBMS is SQL. This is something we will discuss in our CO2. In detail we will discuss there. Here we will just discuss about the basics of SQL. So what is the full form of SQL? Structured Query Language. Okay. So what it does, it provides an interface to the RDBMS. So when as a user you want to work with the database, you need an interface. Now what is an interface? We will just come after that. So for the time being we can understand interface is a link between the user and the database. Okay. So that link is provided by the language SQL. DBMS applications store data as a file, whereas RDBMS stores data in a tabular form. Now there are two terms we are using. First one is DBMS, second one is RDBMS. In DBMS applications, the data is stored as a file, whereas in RDBMS, the same data is stored in the tabular manner. Okay. SQL provides a suitable platform to store, access, modify and update the data in tabular form conveniently. Now since we are saying tabular form, automatically meaning is we are handling with the RDBMS kind of. So what SQL will do, it will provide you a platform where you can store the data, you can access the data, you can modify the data, update the data whenever it is required. Some important functionalities of SQL is to create tables. First thing, since the data is stored in the tabular manner, so first thing you should learn in SQL how to create tables. So SQL give you the platform where you can create the table. Then some other functionalities are like you can insert data in the table, you can delete the data, you can update the data as and when it is required. Okay. The structure of the tables can also be modified in SQL as per the requirement. So when we are creating the table, we are deciding about one particular structure, how my table look like. But it is not a fixed structure kind of. Whenever it is required, SQL provides you the option that you can even define, you can even change the structure of the table. Okay. Moving further, DBMS language. Now SQL, basically SQL support following languages. There are data definition language, in short it is widely referred as DDL. Another one is data manipulation language, it is referred as DML, and third one is data control language, which is referred as DCL. All these things in detail we will discuss. How to do these operations we will discuss in our CO2 discussion. Okay. So now just going briefly, in DDL used by the database administrator. First of all, DDL language is used by whom? Database administrator and database designers. What they do? They specify the conceptual schema of the database. So the database administrator and the database designers, they use the DDL language for what purpose? They use for the specifying the conceptual schema of the database. Now the second point says, in many DBMS, DDL is also used to define internal and external schema. Mostly the DDL is responsible to define the conceptual schema. However, in some DBMS, it is also used to define internal and external schemas. Again, in some DBMS, separate languages are used to define the internal and external schema. Like you can see, storage definition language, SDL is one option. View definition language, VDL is used to define internal and external schema respectively. What does it mean? Some DBMS we have DDL will specify the internal as well as the external schema also. However, in some DBMS for internal schema we are using storage definition language, and for external schema we are using view definition language. Okay. This thing already we have said. Apart from DDL we have DML also and DCL also. Now moving towards the interface. Interface, what does it say? A DBMS interface is the abstraction of a piece of functionality of a DBMS. Now interface, what exactly it means? as I said, it is a, we can say that it is a communication point, it is a meeting point of users and the database. By using interface, users can use the functionality of a database. Okay. It usually refers to the communication boundary between the DBMS and the client. As I said, the users and the DBMS both can communicate, both can interact with each other using this interface. Now, this DBMS interface hides the implementation of the functionality of the component it encapsulates. So what it does, it will just give you the thing what is required. You will just implement the functionality without thinking how the functionality is built, how the functionality is working. So as a user, my part is just to use the database, use the facilities of the database. So interface will give me only the implementation detail. That DBMS interface will give only me the option to use the database. It hides the implementation details, how these things are done. Okay. Now, what some are the commonly used interfaces are there, like menu-based interface is there, form-based interface is there, graphics-based interface is there, which is widely known as GUI, graphics user interface, natural language interface is there, interfaces for parametric users, and interface for DBA and database designers. So these are some interfaces which are used in the DBMS. Now, just going through the points. Menu-based interface, it is widely used for web browsers. So menu-based interface is mostly applicable in the case of web clients or web browsers. What they do, they present the user with list of options called menus. So since the name says menu-based interface, here the interface is based on the different option. A list of option will be given. That option is called menus. Now, what is the advantage of this? Menus do away with the need to memorize the specific commands and syntax of a query language. Normally we need to learn the commands and syntax for to operate any query. If we want to do any query, we need to learn the command and syntax. Menu-based interface, what it does, instead of doing this, remembering this command and syntax for every query, here the query is composed step by step by picking options from a menu that is displayed by the system. In menu-based interface, user will get the different options, which is called as menus. So in the given option, user will select the query, what they want, different options they will select, and this combination can create a query which will be handled. Pull down menus are a very popular technique in web-based user interface. That is one of the commonly used technique for the creating the menus kind of. Next one is form-based interface. A form-based interface displays a form to each user. In menu-based, the menu is given to the user. Here the form will be displayed to the user. User can fill out all of the form entries to insert new data, or they fill out only certain entries in which the DBMS will retrieve matching data for the remaining entries. So the form is given to the user. User will fill the form accordingly as per their requirement, and the things will be done. Forms are usually designed and programmed for naive users as interfaces to CAN transactions. So forms are mostly designed for the we can say that the end users or naive users. Many DBMS have forms specification language, which are a special language that help programmers to specify such forms. So how to create the forms, for that specification language are there, which is specialized for only to create the forms. Okay. So we can say that menu based works on the menu and form based works on the form given to the user. Next one is your graphical user interface, a very widely used interface. Interface displays a schema to the user in diagrammatic form. Now this interface, what it does, it shows the same schema to the user in a diagrammatic manner. The user can then specify a query by manipulating the diagram. So once the diagram is given to the user, they can specify a query by manipulating the diagram. By making changes to the diagram, user can say that what exactly query they want. In many cases, GUI utilize both menus and forms. Now graphical interface uses the previous two interfaces. Sometimes it will go for the menu based interface also, sometimes it will go for the form based interface also. Now natural language interface. These interfaces accept requests written in English or some other language and attempt to understand them. In natural language, what happens, the query is given in the form of request which might be in English language or some other language, and the interface tries to understand them. A natural language interface usually has its own schema which is similar to the database conceptual schema as well as dictionary of the important words. So when we put a request when we put a request in any understandable language form, the interface will try to understand the request. It will take the help of the database conceptual schema as well as the dictionary of some important words. The natural language interface refers to the words in its schema as well as to the set of standard words in its dictionary to interpret the request. Once the interface has got some request, so it will check the request to the schema as well as the dictionary, and it will try to interpret what exactly the request is. If the interpretation is successful, the interface generates a high-level query corresponding to the natural language request and submit it to the DBMS for processing. Once the interpretation part is successful by the interface, it will create a natural language request. It will create a high-level query according to the request submitted by the user, and that query will be sent to the database management system for the processing.